So here is section 3.3, angles formed by transversal. So first we're going to do a little algebra review solving compound inequalities. There's two types of compound inequalities. There's the and, which means both things must be true, and then we have the or, where only one of them has to be true. So looking here, you can literally see the word or and the word and there's a couple of different scenarios we could have. Normally, ors, look something like this, where they're facing opposite directions, and ands are a little bit of a segment. Cool. But occasionally, you might have two things that are overlapping, and so they might look like this, here and here. So we only want the section where they are overlapping. Versus an or, sometimes you might have one facing one way and another facing the other, where only one of them have to be true. This would be an example of all real numbers. Okay, so let's just do the review. So x is less than x is less than -1, so I have -1, I have an open circle because it's just a less than, and the arrow is going to the left because it matches the inequality as long as the variable's on the left side. Or x is greater than 2, so I have a closed circle at 2, and then the arrow goes this direction. So I have an or. Only one has to be true, so this is the solution. We didn't have to solve this at all, it was solved already. Same way with number 2, this is it, it's solved for us. This is technically an and. So, but I can split it into two different parts. I can say x is less than or equal to 4, and then if -3 is less than x, that means x must be greater than -3. So I go to -3, I draw a closed circle, and the arrow goes this way. And then so I can draw it that way. I go to 4, I close my circle, and the arrow goes that way. Since this is an and, I want where they are overlapping, so they're going to be overlapping in the middle. Another way to show this is I could have drawn the arrow going this way, then this arrow going that way, and what we really want is just where they're overlapping, so it'd be from -3 to 4. Okay. Number 3, let's see. I have -x is greater than -3, so multiply by -1 on both sides because I just want x by itself. You flip the direction inequality, and I have x is less than 3. So open circle, arrow goes that way. Let's see. I need to get x by itself, so add 3 on both sides. I have x is less than 9. So 9 is here, open circle, and I need it to be less than, so it's going this direction. This is an and, so I only want where they overlap. It looks like they're overlapping here, starting at 3. So the overall answer would just be this guy. That's it. Because I can't have any of these numbers between 3 and 9 because they don't satisfy both equations. When you have an and, both sides must be true. I must have both these inequalities true, whatever number I plug in. Alright, and then last one. Subtract 2 from both sides. I have x is less than 3. Or add 1 on both sides. X is greater than or equal to -3. Alright, so at 3, I have a filled circle. And it goes to the left. Alright, so I was just graphing that guy. And now I want to grab this one. Go to -3, which is here. Close circle. And I want to go to the right. Since this is an or, as long as one arrow is covering it, we're good. So technically the answer is all real numbers. That's it, because they are overlapping everywhere. Alright, let's keep going, right? So that would be the solution. So whenever you have an and, the solutions are anything overlapping versus an or, the solution would be like anywhere you actually just have an arrow. Alright, so a transversal is a line that intersects two or more coplanar lines at different points. So notice the transversal is the line, is the thing crossing. It's crossing multiple lines. And then the angles formed by the two lines that are transversals have special names. So all of these angles have special names. So I have 8 angles formed, and they all will have special names. So interior angles are angles that are inside the two lines, and exterior angles that are outside the lines. So these are going to be my interior. And then this is going to be my exterior. Exterior is on the outside. So let's do the interior first. So the interior angles are going to be angle 3, angle 4, angle 5, and angle 6, versus the exterior angles, angle 1, angle 2, angle 7, and angle 8. Corresponding angles. Corresponding angles are a pair of non-adjacent angles that are on the same side of the transversal where one is interior and the other is exterior. So if I pick one in particular, right, let's pick 3 and 7. Sorry, let's pick 3, right, and let's go through the rules. So they're a pair of non-adjacent angles, so I have to X out the adjacent angles. They're on the same side of the transversal, so all of these ones on the right side I cross out because they're not on the same side of the transversal. Then 1 is interior, okay, 3 is interior, and 1 is exterior. So 5 is also exterior, is also interior, so that's why I cross it out. So I'm left with 7. 7 must be the corresponding angle. Now the way I think about it though, is they're roughly the same location. This is another way to go about it. So I said 3 and 7. So if I would take this part, 1, 2, 3, 4, and then I take this intersection, 5, 6, 7, 8. They're both in the bottom left corner. They're both in the same relative place. Right? If I would overlay these two intersections on top of each other, you know, they're both in the bottom left corner, the southwest corner of our intersection. So in the same relative location. The other angles we have are 2 and 6. Let's see, 1 and 5, and 4 and 8. All right, alternate interior angles. Alternate interior angles. So interior means on the inside versus exterior means on the outside. I think those are the colors I used before. Yep. Okay. So alternate interior angles are a pair of non-adjacent interior angles that lie on opposite sides of transversal. So if I say 3, it's not the one that's adjacent to it, and it's not the one that is on the same side. It's the one that is across, right? It is on the other side and then down on the other intersection. So angles 3 and angle 6, and then our other angle would be angle 4 and angle 5. Notice they're not right next to each other. They are on opposite. They're on 2 different intersections, and they're across the street from each other, across the transversal. Same way down here, the alternate exterior angles are both going to be exterior angles, and they are on opposite sides of the transversal, and they're not next to each other, right? They do not share a common side. Adjacent angles share a common side. 2 and 1 angles share this side. That's why 2 is not the alternate. All right, so I have 2 and 7. Same side interior angles. So the interior angles are these ones that are inside. And they're the same side. That means that on the same side of the transversal. So we have angle 3 and angle 5, angle 4, and angle 6. Describe the relationship between the angles. So angle 2 and 7, let's see. Angle 2 and angle 7 are alternate exterior angles. Right? They're on opposite sides of the transversal. They're both exterior angles. That's how we'd start out. We'd say, okay, well, both of these angles are exterior. They're on the outside. And they're on opposite sides, alternate sides of the transversal. All right, let's do 3 and 5. 3 and 5 are both interior angles. And they're the same side. So therefore we call them same side interior. They're on the same side of the transversal. Right, they're both on the left side of the transversal. All right, 1 and 5, they're in the same relative location, right? The top left of the intersection. So therefore we would say they're corresponding. 4 and 5. 4 and 5 are both interior angles, but they're alternate interior angles because they're on opposite sides of the transversal. 4 and 8 are corresponding. They're both the bottom right corner of the intersection. And then 4 and 6. 4 and 6 are same side interior. They're the same side of the transversal, and they're both interior angles. They both are sandwiched between the two lines that are being crossed. All right, so we want to use this diagram to name each pair of angles, right? There's more than one correct answer. So for instance, corresponding angles, I could say 3 and 7. I could say 4 and 8, 5 and 9, 1 and 4, 1 and 8, 2 and 6, 2 and 10, 6 and 10. There's so many. There's 9 different answers we could give. Since this is a screencast, I'm just going to give a couple. So let's see, 3 and 7. Let's see, 1 and 4. Let's do 2 and 10. Right, there's 9 different answers you could give, but you only needed one correct answer. All right, alternate interior angles. Alternate interior angles. I could say 3 and 2, right? Because if I'm looking at these two lines in this transversal, they would be the alternate interior angles. Just depends which lines are you looking at, right? Clearly, this is the transversal because it's the one that's crossing all of them. But according to the, which two lines, according to those lines, which ones are the interior, which ones are the exterior. So angle 2 and angle 3. I could also say, let's see, angle 2 and 7 would be alternate interior angles. I could say, 6 and 7, 5 and 8. There's lots of examples. Alternate exterior angles. So I say 1 and 9. I could say 3 and 10. Because for the first example, I was using these two lines and that transversal to determine which ones were exterior. Then for the second example, I was using these two lines and this transversal to decide which ones were exterior. Same side interior. I could say angle 5 and 7. I could say angle 6 and 8. So 5 and 7, 6 and 8, 2 and 4. All right, and then that is it for this screencast.